This video will show you how to clean data in SPSS. It's very often once a research study or a project has ended and data is collected and gathered and inserted into a statistical software such as SPSS, the first step and the most important step that have to be done or need to be done is to visualize, look at your data, examine your data, screen your data, and then do a data cleaning before performing any statistical analysis on the data collected or gathered. So it is essential step pre-performing statistical analysis is that the data has to be examined thoroughly, scrutinized to remove any errors in the data and clean the data and prepare it to be ready for further statistical analysis. Data can be classified or organized or sorted into three major variable or data types. The first one is the continuous variable or continuous data, which can include interval or ratio. So it is a scale data, it is a numeric data. The second categories or the second type of data is the nominal data. Nominal data is non-numeric data. It has categories in it, classes such as yes, no, life, dead. So it is called nominal data. Nominal data can be binomial, in which there are only two categories in it, such as agree, disagree, yes, no, life, dead. Or it can be multinomial. Multinomial data or variable have at least three different categories in it, such as occupation. You can be a doctor, a dentist, a pharmacist, a teacher, and so on. This is called multinomial variable or data, as it has in it multiple categories in it. The third major type is the ordinal data or variable. Ordinal data is categorical data but have order in it, such as first, second, third, and fourth, such as education, bachelor degree, master degree, PhD, as there is an order in these categories. And such as also the Likert scale that is commonly used in survey and questionnaire, in which the participant can select and response by choosing whether or based on whether a 5 Likert scale or a 7 or a 9 Likert scales, a scale from 1 to 5, which is 5-point Likert scales, and 1 is strongly disagreeing and 5 is strongly agreeing. So there is an order in that category. This is called ordinal data. So it is trivial that the data has to be screened and examined for incorrect scores or values, for improper formatting of the data, for not assigning the right variable type for the data, variable types such as continuous, ordinal, or nominal. Data that have in it scores or values that are inconsistent, scores that are irrelevant, scores or data that are duplicated, and missing data And finally, the outliers. So those some of the things that you need to look for when you examine and scrutinize a data extracted from your research study, and to make sure that the data are cleaned and clear to move ahead for statistical analysis. So when these errors or inconsistency of values are found on the data, then either to remove these values or score, or to modify them. If you find this video useful, do subscribe to the channel, leave any comment in the indicated box, and activate the notification bell to receive the recent and latest release into the channel of several different video clip, and click on the like icon and share the video link with others, so the channel can expand and improve to include a large scope of different statistical method and how to analyze data using several different statistical packages such as SPSS, Excel, Stata, Jamovi, Statistics, GraphPad, Prism, GPower, Python, and RevMan. Here in this data view in SPSS, I had made a data here for the sake of performing data cleaning on this data. So here we have 100 cases. In the first variable is the name of the individual or the participant or the persons, and as shown from the name, there are males and females. So this variable is a categorical variable, so it has to be assigned a proper variable type. So it is nominal variable. The type is the wrong, as here it is shown. If we click on a variable view, the first one, the name is ordinal. Name is not ordinal. Name is categorical nominal. I will modify this later. So the first variable is a nominal variable. The second variable is a gender variable. Gender can be either male or females, so it is nominal. It's binomial. Here the type is correctly labeled as the measure is nominal, so gender is nominal. The age, on the other hand, is a continuous variable. It is a scale. If we look at the variable here, we can variable view, we can see the age is improperly assigned as nominal. It needs to be scale. For the next variable, which is education, here I placed 4 different education level: GCSE, a bachelor degree, a master degree, and a PhD, and I gave them a score from 1 to 4. So this variable is an ordinal variable. It is categorical variable, but it has order in it, as you only can get your bachelor if you have a secondary degree. You only can get your master if you have a bachelor degree, and so on. So this also mislabeled as nominal. It has to be modified into an ordinal variable. Jobs, again, is a nominal variable, which is properly here assigned the type. Salary is a continuous variable. It's a scale. It has numeric. It has number in it. So this one is given a nominal. This one has to be changed for proper analysis. Otherwise, if you continue with statistical analysis in that format, you will get a wrong outcome and output, and then your interpretation will be wrong. So the salary need to be type changed. And satisfaction here, I had inserted a data based on 5 Likert scale from 1 to 5, 1 strongly disagreeing and 5 strongly agreeing. Again, this variable is ordinal. Here it is assigned as nominal. Home owners, either you are a home owner or you are not a home owner, so it is nominal. It is in fact binomial. So you have two options, either yes or no. And I had given this assignment of value 1 for you do have a home, 2 you don't have a home. So this one is assigned properly as a nominal variable. Family member again is a number, numeric, so it's assigned nominal. Here it has to be modified into scale measurement. Credit is a scale variable or a continuous variable, as it is measured in dollars or pounds. So this need to be modified, the type of the variable. And the cars, again, whether you how many cars do you have in your household, 1 car, 5 car, 4 cars, and so on. So this variable again is continuous variable, scale variable, and here it's mislabeled as or misidentified as a nominal variable. So let's check the measurement for each variable. Again, here I had assigned this first variable name, which is the names of the individual, as a type of a string, and then I will modify that into nominal because it is nominal. So this one here will be, the names will be nominal rather than ordinal. The gender again is nominal, but in SPSS I had inserted here a type of numeric, and then I'm going to assign 1 as male and 2 as females. So here this one is nominal measure, which is properly assigned. Age is a scale, so I'm going to modify that into a scale. So age is a scale. Education, as I have explained, is an ordinal, so I'm going to select the proper measurement type or variable type. Again, a type here is given a score from 1 to 4, and I had inserted several qualification from that education. For jobs, it is nominal. Again, it's correct format for the variable type, as it is nominal. For the salary, again, there are 2 mistakes here. It is string, which is wrong. This is not a string, this is a numeric, so we need to change that into numeric and then modify the measure into scale. So the salary has to be numeric and has to be scale. And if we go back again here, the salary is now corrected into a scale. As you can see, the icon here for the scale variable, the icon for multinomial, the icon for ordinal, and the icon for binomial. Back again to the variable view. Moving to the satisfaction, as I have mentioned, 5-point Likert scale is an ordinal, so I'm going to select an ordinal here. For home owner, whether you are a home owner or not a home owner, yes, I put the type as numeric, and then I can select whether it is yes or no. So this will stay as a nominal. For family member, again, the type is wrong here. It has to be numeric, okay? And the family member is a scale. If we look at the family member here, we can see that it is now changed into a scale variable. And for the credit is a scale. continuous variable, and the number of the cars in for a household is a scale. If we look back again into this, it is definitely now the type of a variable has been corrected and each variable is assigned the proper variable type. Names are nominal, gender are binomial, age scale, education is ordinal, jobs are nominal, salary scale, satisfaction ordinal, home owner, yes or no is nominal, family member is scale, and credit scale and cars are scales. So to clean this data, the first step is to look at the scores or the values within each variable. Let's pick up the first one, which is the names. If we click on analyze and then scroll down to descriptive statistics and then click on frequencies, reset this, I'm going to select the variable which is a nominal variable into the box under the variables, and I'm not going to check anything here for mean and median, as the variable is categorical, and keep this box ticked in display frequency tables. Click on OK. Two tables are generated. The first one showing that there are 100 valid scores or values, no missing values here. However, if we scroll down in the second table and examine each participant or individual names and look for frequency, and if we scroll down here, we can see Elizabeth is recorded or reported twice, and scroll down here, you will find that Vincent is recorded twice. Whether they are the same person or not, as here the surname is not given. If we go back again to the data view and look for Elizabeth somewhere here, yeah, Elizabeth case number 91 and 92, examining the data or the scores for these two individual, it is clearly this there is a duplication in the scores for this lady. So then the best way for that is to delete that score, as it has been inserted twice. Scroll down to Vincent. Again, there is a duplication in the entry for that individual. So let's clear that person. So now we have reduced the number of participants from 100 to 98. If we go back again and click on frequencies and repeat the same thing, the same analysis, two tables, valid number 98, and look at the frequency, they all have no duplication. So this is one of the steps that need to be taken when cleaning a data and scrutinizing the data. Looking at the second variable, which is the gender, and I'm going to assign value 1 for male and value 2 for females. And the way to do that, if you click on variable view and select the gender variable, and in the value here in this cell, click on it and then insert a value of 1 and give it a label of males, and then insert a value of 2 and give it a label of females, and then click on OK, and back again to data view as shown here. If we click on that icon here, the proper labeling is given here, untick that. If we examine the gender variable by eye, first of all, we can clearly spot there are two typing error. But let's do it through the software. If we click on frequencies and then deselect that one here and then select the gender and click on OK. 2 tables, 98 cases valid for gender. The second table shows here that there are males and females, 49 and 47. However, there are scores of 22 and 111 is not identified by the software as whether it mean a male or a female. So most likely, if we go back again to the data view, this could be a typing error. So instead of typing 2, it has been done twice. So change that, modify it to 2, and this probably a typing error for 1. So now that this variable or this data is cleaned from the error, typing error in it. The most important thing also that to notice that whether the individuals here are assigned the right gender. We said that males are 1 and females are 2. Here Carol is assigned 1, so there is a mistake in assigning the proper gender for this individual. Alex is assigned as a male, which is correct. Maria is as a male. So this has to be checked thoroughly to make sure that names correspond to the gender. So Carol has to be modified to number 2, Nathan, then Alex, and then Maria to 2, and so on. So you need to go through each individual score and cross match it with the names to do the rest. Moving to the third variable, which is a continuous variable, which is an age. Clearly I can spot by eye there is a missing value here, a missing value here, which I made, a missing value here, and a missing value here, and a high value which is 200 and 170. If we go back again and look at the frequencies by selecting the age and clicking on OK, here it shows that the age has 4 missing values in it. Looking at the second table towards the ends here, you can see that the age ranges from 19 inserted in this data or for this data up to 65. However, there is 170, and this is properly an extreme value, and I guess that that could be a typing error. Instead of typing 17, typed 170, and 200 also might be also a typing error. So need to go back again and check your original data and see if that's a typing error or it is something else. Then most likely the person who has done the analysis maybe mislabeled this, either remove this case or change it into most likely an age of 20. So if I go back again to the data view, let's change this to 20 after we made sure that it is a typing error, and then 17. So now we have the data cleaned for this extreme values, high values, which cannot in real life be real. What to do with the missing value? Since we have here a scale value, a continuous variable, then there is a way to deal with this missing value. Either omit this value from your statistical analysis or replace the missing value with the mean for that variable. And the way to do that is to click on transform and then scroll down to replace missing values, and in the new window here select the method for replacing. Here I'm going to stick with the serious mean, and I'm going to drag the age into that new variable and give it a new name, because that software will generate a new variable and modify the missing values and add value for the missing value in the variable, and keep and retain the original variable. So let's call it the age 1 and use the age 1 label for that new variable, and replace missing values with the series mean. If I want to do another variable, then just click on it and drag it to here. So if I click on OK, again a table is generated in the output of SPSS, showing that a new variable is generated and created a new scores for missing values using the S means, and these missing 4 values has been replaced with the mean. And if we look back again to the age here, in the again look toward the end here, a new variable is generated, and the missing value here at number 4 values has been replaced with the age of the individual, which is the mean age. The way that mean is inserted, if we go back again and do frequency and then select, let's select here mean and median and click on continue and then click on OK. The mean for the data age or the variable age is 42.05, and that value has been replaced for each missing score in the age variable. So a new variable is generated. Moving to the 4th variable here, which is an education. Education is, as I said, ordinal variable. If we click on data view, we see that education is an ordinal variable. There are 4 classes I had inserted in that, 1 to 4. Let's us insert a value for these classes by clicking on the values here in this cell and then adding 1 for, let's say, GCSE, and then 2 for bachelor degree, and then with a dot, and then 3 for master degree, MSc, well, C has to be capital letter, MSc, and then PhD, which is 4, and if I type here PhD, and then click on OK and go to data view, click on the icon here as shown here. The numbers has, or the values has been assigned a categorical description, which is PhD, master, bachelor, and so on. Revert that back again to the numbers. Again, as I can see here, now the education has properly formatted for the values from 1 to 4. However, I can spot here error such as 0, and then missing value here, and then a number of 7. Let's go and do the statistical description. Remove the age, bring the education. Let's keep the mean and the median the same. Let's go for the minimum and the maximum here and click on continue and then click on OK. As shown here for the education, there are 2 missing values, 96 valid scores. The mean is 2.5 and the median 2.5. Minimum 0. There should be no 0 in this categories, that is from 1 to 4. So this is a mistake, error in typing. Need to go back again and check the original data. The maximum is 7. Again, there is no 7 values here. So the best way is to go back again and check the original data. So 0, either remove that or replace it with the correct value. And for 7, again, that is not included as a score in the variable. So these 2 values has to be looked at and modified. The rest is look like normal. GCSE 22, BCPS 25, Master 25, and PhD is 22. So there is a missing value here for the education and a missing value here. It has to be checked with the original, either to omit that value For the 7, again, you need to do something about that. Check the original and then assign the right value. Moving to the job variable. The job variable have 5 categories in it, and to go back again to the variable view and select the jobs and then assign the values of a label by giving 1, let's say here 1 is for doctors and 2 for nurses, 3 for pharmacy, and then 4 for teacher, and 5 for dentist. Click on OK and back again to data view and tick on this. Again, the numbers has been assigned a value here. Untick this back again, revert that back again to the numbers or values. By eye, if we scroll through the jobs, we can see there is a value of 0 here. If we click on analyze again and go for frequencies and then remove the education, bring the jobs here, and then let's keep the median and the mean there. However, this is a categorical nominal variable, and if I click on OK, looking at the second table here, only the 0 value and everything looks fine. So back again to that, and then this has to be modified and look back again to the original data and assign a value for it from 1 to 5. Moving to the salary. Salary again is an scale or continuous variable. I can spot by eye. Salary cannot be in minus. Here it's an empty cell or empty, no value, missing value here. So to deal with the salary, again, click on frequencies, remove the jobs, put the salary here. Let's keep the statistics for mean and median, maximum and minimum. Click on continue, click on OK. So we have here one missing value. We have the mean, the median, and we have a minimum and a maximum. The minimum is minus, so this probably a typing error. You need to remove the minus. You need to double check the original data, and most likely this is a typing error. And this missing value, we will deal with it shortly. And if we look at the second table, the frequency so far okay, 97, and on the top there is the minus here, and there should be a missing one here. So to go back again and let's modify this, change it into positive sign, and to replace this missing value, since it is a continuous variable, do the same as we've done before. Select the transform, click on transform, click on replace missing values, reset this, select the salary, and then select the series mean, drag it to here, a new variable will be generated. Click on OK. Table is generated here as shown that the salary 1 has been generated as a variable with one missing value replaced with the series mean. And if we look back again into the select that score here and scroll toward the ends, and as we can see, the missing value is replaced with the mean for that variable. Moving to the next variable, which is satisfaction. Satisfaction is based on the 5-point Likert scale from 1 to 5, and by eye we can see that there are several incorrect scores or values here. But first of all, let's give and assign each value a label by clicking on variable and then go for variable view for satisfaction, and then on the new window here, assign the 1 for strongly disagree, and then 2 D for disagree, and then 3, 4 neither agree or nor disagree, so we'll give it an N, and 4 for agree, and 5 for strongly agree. So this has been assigned a proper label. If I click on OK, data view, click on that icon here, it has been assigned the proper label. Back again to the data here. Let's examine the data. Look for frequency, click on frequency, remove the salary from here and bring the satisfaction to here. And for satisfaction, let's keep the same selection, click on OK. Table is generated here showing that there are 4 missing value for satisfaction, and the mean is calculated, and the median here we are more interested in the median as it is ordinal data. These data are ordinal data. There is a value of -1 and a value of 0. So this probably typing error for 1 and this for 4. And if we look at the second table, there is 1 score for -1, 0, 1, and there is also a value of 40. So we have here 3 incorrect values, -1, 0, and 40, and 4 are missing. And the way to replace this, probably -1 with 1, 40 with 4. So let's make this correction. So let's go for satisfaction. We have 1, 2, 3, 4 missing. This one, correct that into 4, and that's 1 into 1. And for the missing here, 4 missing values, the way to deal with that, so we could replace the missing values by the median, which is 3, as shown in the output for description, and that will fill the whole the missing values in this variable. There is another way to replace this missing value for satisfaction is by clicking on edit. First of all, select the variable and then click on edit and then replace, and then insert the empty here and the value for 3, which is the median. This is another way of filling the missing value or values if the data has multi-thousands of entries in it. Moving to the next variable here, which is a homeowner. Again, homeowner is a nominal variable, binomial variable. Either you are a homeowner or not. So to look at the variable view and click on the homeowner, then assign a value of 1 for yes, I am a homeowner, and 2 for no, I'm not a homeowner. Click on OK. Double check that the values are placed here, as we can see, yes and no. Untick this. Now, examining and looking at that variable, we can see that there is a value of 0.22. Again, this could be a typing error. There is a value of -2. There is a value of -1. Click on the frequency analysis, move satisfaction, and then click on homeowner, bring it here. Looking at this table here, there is no missing scores in the data. However, there is a value of 0. The minimum is -2 and the maximum is 2. Looking at the next table here, as we can see, there is a value of -2, a -1, and a 0 value. So, and also a value of 0.22. So there are 1, 2, 3, 4, 5 incorrect values or scores. I'm going to correct them. If we click back again into the data view here, and this 0, we need to go back again and check the original data, whether it is 1 or 2, yes or no. This one probably a typing mistake, it's 2, and this -2 is also a typing mistake, -1 also a typing mistake. These are not missing value but wrongly typed as 0. So original data has to be checked to verify. Moving to the next variable, family member. Repeating the same steps, click on frequencies and then select the family and then select OK. And since families are a scale or continuous variable, the mean is given and the median. The mean is 17.8 and there is a missing value. And scroll down here, you can see that there is a missing value. And the way to replace this missing value is to go back again and check the original, and if there is no data, then this can be replaced by the mean for the variable family members. So this is the way to clean data, remove from it any missing or mislabeled or incorrect or irrelevant or duplicate data or improperly formatted or inconsistent data or even outliers. I had not covered outliers in this video, but I do have several videos addresses the outliers and how to deal with outliers when you have a data with an outliers, whether to remove that outliers if it was wrongly inserted, or to handle these outliers using different facilities available in the SPSS software, such as transformation. Outliers in general are extreme high or low values that is different from the rest of the scores or values, deviate from them. In conclusion, it is essential and important to clean your data before you move ahead to the statistical analysis. If you are a student or a researcher and you have a data, whether it is quantitative or qualitative, and you want to perform statistical analysis on that data using any of the softwares listed here, whether it's SPSS, Excel, Stata, Jamovi, R Statistics, GraphPad, Prism, RevMan, GMP, Python, then do contact me to arrange for either a one-to-one private tutor session or a training course on any of these statistical packages. My contact details are given here, so don't hesitate to write to me or email me if you need a private one-to-one tutoring or a training course.